All right, looks like we're live here. So good morning, good afternoon if you're across the country in a different time zone. I am Paul Kruger. I am the CEO of the South Dakota Mines Center for Alumni Relations and Advancement, and I am hosting the webinar today. We have a new Alumni Director that some of you may have met on our last webinar that we did last month, Shelly Grenager. She'll start with us on Monday, and she'll be the host of these events moving forward. And Sarah Von I, we had a send off for her on our last webinar, and wish her well as she moves to a new role here in Rapid City. So glad you're here today. A couple housekeeping items before we get started. We are recording today, so we, if you want to go back and watch this, or there's somebody else that you'd like to let them know that you enjoyed today's session, you can go to our YouTube channel. So that'll be out there within a couple of days. It'll be out on our YouTube channel. And you can use the chat function today if you want to say hello to everyone, share your class and major, and share it with everyone. So those are just a couple housekeeping items. We will have time for questions at the end as well, and then I'll give you a couple other reminders about events coming up. So our speaker today is Dr. Pierre Larochelle, one of my favorite names to say on campus. I think it's just it's a great name. But he is our department head and professor of mechanical engineering. He's been with us since 2017. Previously, he was an associate dean and professor of mechanical engineering at the Florida Institute of Technology. His research focuses on the design of complex robotic mechanical systems and enabling creativity and innovation in design. He is the founding director of the Robotics and Computational Kinematics Innovation, or ROCKIN laboratory. He has over 100 publications, holds 3 US patents, and serves as a consultant on robotics, automation, machine design, creativity and innovation, and computer-aided design. So it's just a real brief introduction. There's a lot more we could say about him, but working with Dr. Larochelle from the development standpoint, we are just really blessed to have you on our team, Dr. Larochelle, and look forward to having you visit with our alumni and friends today. So I'll turn it over to you, sir.
Well, thanks a lot, Paul. I appreciate the opportunity to always chat with our alums. Always end up hearing great stories and hearing great anecdotes and getting some great feedback as to how we're doing here at the School of Mines. I thought I'd do something a little bit different. I've got a few slides I'm going to share with everybody, and then what I thought I would do is we're going to take a walk around, and I'm going to show you. I'm going to try and show you with my cell phone, walk around the CM building a little bit, and show you some of our labs and facilities that we have here in the department. And so I'm going to start off with a few slides. So hold on while I share my screen here. All right, so here we go. I thought I'd start off by you know, I'm in a good mood. We just had a nice holiday, so I thought I would share some good news and some numbers that show some of the successes and how we're doing pretty well here in ME. The last fall's career fair had the usual large number of recruiters, and if you're not familiar with other schools and other universities, it is phenomenal, the large number of recruiters that come to the School of Mines here for the size school we are, especially. We had 119 recruiters here at our career fair in the fall. And I've got friends that lead ME departments at schools with 50, 60, 70,000 students, and they don't get 100 companies coming to their career fair. So that's a huge testament to the quality of the graduates coming out of the School of Mines. So we had 119 recruiters come to our career fair last fall. Anybody want to venture a guess as to how many we're looking to hire ME students out of those 119? You can put it in the chat. You can unmute if you want. Anybody want to take a guess as to how many of those 119 recruiters wanted to hire MEs? Oh, I see all of them, 70, 105, right? All 119, okay. 83 out of the 119 were coming, wanted to hire ME graduates. Fantastic, as well as hire ME students for internships and co-ops. So lots and lots of demand for ME students. We also had a virtual career fair for those recruiters that couldn't come to campus in person last fall. So we did both. There were 78 companies, and these are different companies that came and did our virtual career fair. And I'll ask the same question again. Out of those 78, how many are looking to hire ME students? Well, you get an idea, right? It's about the same ratio. 52 out of the 78 wanted to hire ME students. So I always enjoy the career fairs. I get to meet a lot of our alums because a lot of the recruiters that come are alums of the program. And again, get a lot of good feedback and hear a lot of good stories about the ME program here at the School of Mines. So I thought I'd start out with some good numbers like that. We just a couple of weeks ago received from our Career and Professional Development Center information about our academic year 20 graduates. So those are students that graduated in May of 2020. So their average starting salary was $64,246, and that's nationwide in the United States, right? So, you know, there's geographic variations and stuff like that, but that's a great number. And that number has been trending upward even in the pandemic and as we exit the pandemic. Our placement rate for those graduates and School of Mines and our Career and Professional Development Center, I got to give them credit. They do a real placement rate. It's not, do you have a job? It's, do you have a job in your field? So we don't count people that are, you know, flipping burgers or whatever in between jobs or anything like that, or well, they're still searching. Our placement rate for those graduates is 99%. And that's, you know, during pandemic and all this stuff. So that's huge. And literally that 99% is one student who's hanging around in Rapid City waiting for their girlfriend who's a year younger to graduate. So that's fine. And that's fine by me because I really don't like going up to 100%. We've done it a couple of years ago because the only thing you can do from 100% is do what? Go down, right? That's no fun. So 99, 98, you know, one student's got some special thing going on. Like a few years ago, we had one student that graduated and their graduation present from their family was, okay, you can go backpacking around Europe for a year. So that's what they did. So we were at 99 that year. And that's fine with me. Oh boy, the slide got busy, right? The screen got busy. Yeah, I don't know. Maybe I'm crazy for showing you our curriculum flow chart. I don't know. You can let me know. Why are our students in demand? It's because they get great education. And the great education, one way to show how we do it in terms of a big holistic picture is with this big flow chart. And the reason I wanted to show this is because, you know, the coursework and the project-based learning and the hands-on experience that our students have is why our students are in such demand. The recruiters tell us over and over again that the project-based learning that our students have, the solid foundation in the engineering science fundamentals. I mean, our students learn the theory, but they also learn how to put it into practice and make things happen. And that happens in their coursework. And just to show you a little bit how this is laid out, column-wise, it goes from your first semester toward your last semester of graduation, left to right. And then the rows are the individual courses that you take, and you know, and this is the ideal right flow, right? Most students don't follow this flow because, you know, they've got early credits, they've got AP, IB, they took some classes somewhere and all that stuff. But I did want to focus and talk a little bit about the ME courses that our students take. And the ME courses are all color-coded in this blue here. So all these boxes in blue are all ME courses taught by ME faculty. And they are taught by ME faculty. They're not taught by graduate students, like a lot of schools do, especially the large land grant schools. That's the only way they can deal with the numbers and the quantity of students that they have. So, you know, we start our students right away in fall freshman year in an intro to ME course. So they start learning their discipline. They start getting to know each other. They start doing design. They start working with each other. They start project-based learning. fall freshman year. That's huge, right? There are many schools, many programs where you're pre-engineering. You don't really start your engineering program until your junior year. The number and the quantity of ME courses that our students take really gives them an advantage. And where does all this stuff come from? Right? It comes from this idea of our product development theme that we have going through our curriculum, and we do project-based learning throughout that theme. So this slide that I'm showing you now, this shows you our product development theme that goes through our 4-year curriculum. And again, it goes left to right chronologically through our studies, right? So ME 110, our students start learning the product development process, and they start doing their first project-based learning and working in teams in that fall freshman year. That gets followed up with ME 126L and the Design for Manufacturing course, where our students learn about planning and prototyping and designing for manufacturing. So by the time they finish their second course, all of our students are very, very familiar with all our fabrication and shop facilities in our department. They've all been trained on how to use this equipment. They know how to work with our support staff, our mentors, our technicians, so that from now on, as they go through their studies, they can be in any class and the prof can assign a project and say, okay, got to go, design this and build me a prototype. Then the students go off and do it. And that's part of that project-based learning, that product development process. In the second year, in their sophomore year, our students take ME 265, which is a customer-focused concept development course that focuses on product design and development. So our students will actually form teams, go out and identify an opportunity for a new product, design and prototype that product, test that product and get feedback from that customer base identified on how well their product satisfied their needs and their desires. That gets followed up in the junior year with a Mechatronics course. And again, project-based learning. And in this course, all of our students, again, on teams, will form multidisciplinary teams and work with our staff and our support infrastructure and our labs and our fabrication shops, and they will design new products that have embedded software in them. So embedded microcontrollers and microprocessors within a product. So they're doing designing and prototyping a complete mechatronic product. And then we have a culminating senior design experience, which is 2 semesters long, ME 477, ME 479, where our students will all, again, in multidisciplinary teams, work to design and prototype a complete product. Now, the products that they do in senior design, about 80% of our projects are industry-sponsored real-world projects. Companies coming to us saying, please, can you have a team of your students work on this? The students, we have more projects than students every year. So we unfortunately have to turn away some companies every year and say, sorry, we just don't have enough students. Not that we don't have a lot of students, but we always have more projects than we have students. So 80% of those projects are industry-sponsored, real-world projects. Again, our students are doing real product design, hands-on learning for industry. The other 20% of the projects are the intercollegiate competition teams like SAE Formula, SAE Baja, NASA Moon Rockers, Super Mileage, Human Powered Vehicle, just many, many intercollegiate design competitions. So we have 15 to 20% of our students each year, which will choose to work on one of those projects instead of an industry-sponsored project. We've been doing really well in those intercollegiate competitions. So I hope this doesn't seem too dry and abstract, but I did want to talk about our curriculum a little bit and talk about this product development STEM that we have through our curriculum, because it all really comes from the legacy that was established by Eldon Stancis when he founded this department and led it for the first 27 years. Right? So Eldon worked real hard to grow the ME program here at the School of Mines, worked real hard to establish that hands-on project-based learning curricula, which has served our students very, very well throughout the history of our department. And so I thought you might be interested in seeing that connection and how that legacy lives today in our curriculum of today. And differentiates our School of Mines mechanical engineering students from the vast majority of institutions in the country. We're very, very proud of our curriculum and the education that we provide our students. And that all really comes from this legacy that was established by Elliot Census. So I'm showing a couple of pictures here. So here's Professor Census right here in the middle, and here's Professor Census a few years later, with some students in the lab. And this is one of the last pictures when he was working and leading the department. Of course, this is before the addition to the CM building, with the mural outside CM building here with mechanical engineering. So at this point, what I thought I'd do is I'd stop and pause and take any questions. And then what I'd like to do after I answer any questions that folks might have, then I'm going to fire up my portable camera, my cell phone, and then take you into the shops and facilities and let you see what's going on here in the department and the resources that we have and what we're trying to grow here in the department. So, Paul, can you help me? Are there some questions?
There is one question, Dr. Larochelle, about the camp. Can you talk about the camp last week, how that went? That's from Dave Bird.
Okay, sure. Dave. Hi, Dave. Dave Bird asks, how did the mechanical summer camp go last week? How many participants? So, okay. Actually, we have several camps that are being run from ME this summer. Dr. Michael Landy has 4 camps running this summer, and they started, I want to say the first one was the first week of June. And that one focuses on design thinking and making. And he offered it twice to middle school students and twice to high school students. So I believe we're 3 of those camps have completed, and another one happens next week. Those camps have proven to be very, very popular. About 25 students in that camp each week. And unfortunately, not enough space for all the students that would have liked to have joined. The camp sold out. So very, very good feedback on that camp. There was another camp last week, and that was run by myself and Dr. Aaron Lally. And that camp focused on industrial robotics and advanced manufacturing. That camp was capped at 10 students. And we had many more students interested in applying for the camp than we had room for, but we had to cap it at 10 students because the hands-on project-based learning that we did in that camp. And so we're limited by the hardware and the lab facilities that we have for that camp. So that camp was very successful. We had a lot of fun. Well, I can show you when we do the walk around here in a minute. I can pop into my lab and show you that the setup is still on with the robot in the lab right now. So show that to you real quick.
And then another question from Gene Hobbs: what companies hire MEs and any transportation related industries?
Whoa, who's hiring MEs? Everybody's hiring MEs. It's a good time to be a mechanical engineer, I'm telling you. So, I mean, we get recruiters coming from everywhere in every facet, every industry, and you just be like, why are they hiring MEs, right? I mean, it's all over the place. ME is such a broad foundational engineering field. When I go out to talk to middle school students, I say, MEs design anything that moves. Anything that moves, the MEs are involved in designing that product or that process. So we've got the HVAC companies. We've got everybody that's going into space and aerospace, right? So SpaceX, Virgin Galactic, Blue Origin, NASA, Northrop Grumman, Boeing, Rockwell Collins. I mean, they're all hiring our students. You get all the big heavy equipment companies, the Caterpillar, the John Deere, the Deuce and Bobcat. they all hiring our students. Manufacturing of anything hires ME students. So anything that's got an assembly line, any kind of automated manufacturing, they're going to hire ME. So automotive industry, for the manufacturing as well as the design of the vehicles. Estee Lauder, the makeup company, comes here and recruits MEs for their manufacturing processes and packaging. Silicon chip makers. Everybody. I mean, it's just all over. I mean, we get recruiters coming from Goldman Sachs on Wall Street wanting to hire MEs because our MEs are so good at running projects and teams. I mean, it's all over the board.
You want to take a couple more questions now then, Dr. Larochelle?
Sure, and then I'll start walking and talking.
Okay. All right. Based on your experience, are there plans to introduce robotics and/or automation curriculum into existing ME courses, or to offer as a senior elective course? That's from Daniel Minders.
Yeah, the answer is yes, and yes. Mechanisms, machines, and robotics is my game. So I've been teaching a senior elective course since I got here in robotics. I've also been teaching graduate courses in robotics. And we have our junior year mechatronics course, which almost always the products that the students are doing in there are robotic projects, usually mobile robots, autonomous vehicles, navigating, mapping, slamming, and doing all those things. So there's a lot going on. Even in the sophomore design course, there's a good number of the products that our student teams design that are robotics related, and using robotics technologies to solve problems. So there's a lot of work going on.
All right, and then from Dick Warder, how do senior projects based on the professional society competitions handle the engineering criteria standards aspect of the major design experience, as the competition rules aren't usually considered to be standards?
Yeah, but the students have to design to standards, and they have to meet codes. And so the students have to learn about codes and standards. You know, I'll just give a simple example. So they're designing SAE Mini Baja, right? So they got to design, the frame for this vehicle. And so then they have to learn about, ASTM standards. They have to learn about material standards. They got to know what the heck a 6061 T6 aluminum is, what the heck chromoly is. So they learn about those standards. They learn about material testing standards. They have to draw the whole thing up in CAD. So they have to learn about GD&T standards. So that's, in a nutshell, that's how we address those codes and standards requirements when our students do intercollegiate competition teams. Because the stuff they design, they still have to use the codes and standards.
All right, and Jerry Jarding has two. I'm going to put them into one question, and I think these will be fairly easy for you. Does your department offer scholarships to students? And then what % of ME students are female?
Scholarships, sure. Scholarships are very, very important at the School of Mines to help reduce the costs of attending. Scholarships are awarded ME students through our Office of Missions and Financial Aid, and the funding for all of those scholarships comes from donations. Folks may or may not know, the state of South Dakota, unlike many, many other states, does not allow the school to use any state funds to reduce the cost of attending the school. So, many of the schools we compete with, the schools themselves will provide scholarships. That doesn't happen here in South Dakota. All the scholarship dollars are donated through CARA and then forwarded to our students. So many of you probably on this call right now have been donating to support scholarships. So thank you if you have been, and if not, something you might want to consider.
And then the other part was female students. What percentage?
Oh yeah. What percentage of female students in ME?
In ME, yep, correct.
In ME, undergraduate ME, we float between 14 and 16%, which is just this much over the national average, which is around 11, 12, 13%. So it's not what we want it to be, but we're better than the national average, but it's something that I've been working on in my role as department head for the last couple of years and trying to grow that percentage here.
And then last one is just a comment from Mark Wojtasek. I'm not sure if I said your name right, but add some electronic cooling to the coursework, he says.
Electronic cooling. Well, I know we have added in our Thermo 2 and heat transfer courses, electronic cooling case studies and examples. So yeah, we agree. That's a big issue.
And then there's one more.
We all have these things, right? We all have cell phones, and the only reason they're small and they can do all the stuff that they do is because they don't melt. And that's a great ME problem. How do you get all that electronics in there and use all that energy and not melt?
One more question, then you can do your tour if you'd like. Are there any classes that incorporate change management and project management? That's from Dale Weiland.
Sure. Yeah. Dr. Aaron Lally created a new senior elective. I'm blanking on the name of the course. ME 455. Actual wording name I don't remember. But that course focuses on project management and change management, as well as designing for quality. And they use PLM and advanced CAD software in that course. So the next thing did we get all the questions, Paul?
So far, there's a few comments in the chat box, but I think we did answer all the questions so far.
Okay. So I thought I'd take a round and we've talked a little bit about the legacy of Eldon Stensis and that project-based learning we have. And I'd tell you some of the facilities that we have here in the department and some of the things we're trying to upgrade. Many of you may have heard we're doing a fundraising campaign to grow the Stensis Laboratory Endowment. The Stensis Laboratory Endowment was created about 20 years ago to honor the legacy of Eldon Stensis and help support the department in providing this project-based hands-on education. And that endowment has served us well, but the costs have gone up so much in the last 10 years. And unfortunately, the state funding has decreased, that we need additional resources. And so we've got this great fundraising campaign to grow that endowment. And we have this matching program from the relatives and the family of Eldon Stensis, his children and his extended family have provided a matching program. So they're matching donations 1-for-1 to the Stensis Laboratory Endowment Campaign. Our goal is to raise $1 million to grow the endowment by $1 million with the 1-for-1 matching, which means which we already have in place, we need to raise 500,000, and that will get us to our $1 million goal. And we're about just under 2/3 the way to that 500,000, $500,000 fundraising effort so far. And that's what's enabling us to continue on the legacy of Stensis, enable us to do the project-based learning and the hands-on learning, because quite frankly, what we get in our state operating budget doesn't come close to covering the costs of doing the project-based hands-on learning that we do. So hold on a second, I'm going to connect.
And I'll just fill in while you're doing that. Dr. Larochelle, I'll put a link in the chat to the Stensis Lab if people want to endowment, if they want to learn more about that. So we'll put that at the end of the time here in the chat so people can link right to that.
Yeah. So here we go. Here we go. Let's see. Let's see, 1 second.
Is your cell phone in the attendees list, Dr. Larochelle? We can promote you if we have to.
Yeah.
What's the name of?
I think it's my initials.
Oh, Piers S20. All right.
Yep.
Promote to panelist. It should prompt you for something, right?
All right. So now All right. Oh, where is... One second, folks. I'm just still trying to...
Looks like you're muted on your phone, Dr. Larochelle, if we can't hear you now.
Yeah, sorry, guys. I'm trying
go.
to change my settings so I can swap my camera. So hold on.
That might be in the top right corner. Looks like two little circles to get it to change cameras.
Yeah, that's what it usually is, but unfortunately I can't.
Maybe you have to activate the camera before it'll let you change it. We aren't seeing either.
Oh, okay, now we go.
Bingo.
All right. All right, everybody still hear me?
Yep, we
Yep,
can hear you.
sounds good.
All right, so ME Department Office. Hi, Brittany. So Dave Berg asked about the robotics and advanced manufacturing camp, so I'll show you the setup that they did real quick. Dark room, lighted room. All right. So what we had the students do in that camp is we had it Star Wars themed. And so we bought these figures. And if you're Star Wars people, you'll recognize them. If you're not, then that's okay, no problem. So we bought these 6 figures, and there's 3 good guys and 3 bad guys, right? And so we told them we want them to design an automated system where the robot picks up a lightsaber, and depending on whether it picks up a red lightsaber or a blue lightsaber, and the blue is the good guys and the red's the bad guys, the robot picks up the lightsaber and goes and helps out these figures that are in combat and knocks out the bad person, right? The opponent. And so these are a team of 10 high school students that designed and fabricated all the tooling, the jigs and the fixtures. So we bought the lightsaber, but they had to design and build all this, including this fixture, the tooling on the end of the robot, and program the robot so that it would do all this, right? So the robot, they wrote the program, so the robot comes over here, picks up a lightsaber, brings the lightsaber over here, turns it on by pushing it down on this tab, extends the lightsaber by flicking real fast like I did, and then it comes over and smacks these things, right? Then it pushes the lightsaber back down and returns it back to the bin. 10 high school kids. Feedback so far has been great. It was the first time we ran that camp. It was, I think, very successful. Now we're going to the east entrance of the CM building where we recognize this, right? Now you know where I am. Thought I'd show you these guys up here. So a couple of aerospace related projects, right? Last year we added an aerospace engineering minor, very, very popular. So there's a rocket designed by a team of students. And up there you see a moon rocker, one autonomous robot designed and built by our students that competed at NASA Kennedy. Now I thought I'd show you some of our shops and facilities. So we're going upstairs. Hopefully no one's getting motion sickness. In keeping, now I'm on the second floor, so now you get a different view of the rocket, different view of the robot. We also put up a bunch of these nice acrylics to, again, support and excite everyone about our new aerospace engineering minor. So we've got, right, the CERN Super Collider, we've got the Mars rover, we've got a quantum computer, right? We've got an ion drive engine, course, the International Space Station, the ISS. Then we got a tokamak, right, for a fusion reactor. We also have an electric paraglider, paramotor, designed and built by a team of our students. How are we doing? Hopefully everybody's still got their seatbelts on. So several years ago, this part of the CM building was called the Integrated Lab. Now we call it the Zoo. It's a big open project space for our students to work on their projects. Benches and stools they can reconfigure so the teams will meet in here, assemble their projects in here. This is more like an assembly and testing and meeting area. Hand tools and electronic supplies for welding and wire connectors and terminal strips and things like that for doing assembly. Some open stock raw materials for them to use. So here's the machine shop where a lot of the stuff gets made. And what I wanted to show you, like, you know, we've got some great machine tools, right? We've got a Haas CNC lathe here. We've got a Haas CNC mill with a nice tool changer in here. But we've also got some machine tools that literally go back to World War II. And so these are some of the things that we're really trying to upgrade. And you know, the earnings from the Census Lab Endowment are really going to be able to help us do that and get some new lathes, some new mills, and some new machines to support our students. Hi, Voz. Voz, our machinist, supporting our machine shop. We're lucky to have him. He's great. All right. Now I'm going to the aquarium. So I showed you the zoo real quick. Well, here's the aquarium. The aquarium supports our embedded software projects, as well as our additive manufacturing. So we have several of our 3D printers in here. We have more, but you know, some of them are in here. We have student employees that help facilitate the use of the resources in the aquarium. So they work at this desk here. And then we have electronic support, which is kind of a mess right now, but it's summertime. It's all just shoved back in this corner right now, but we've got soldering stations. We've got digital oscilloscopes. We've got multimeters. We've got function generators, power supplies that get spread out all over these benches in here. But right now it's all kind of stored in the back here. So this is a facility that's open 24/7 for our students, the aquarium. So is the zoo, is open 24/7. Of course, the machine shop is only open when we have staff in there because of the safety reasons, right? Okay. So I thought that would be a nice way to show you some of the lab facilities and the infrastructure that we have that was made possible by the legacy started by Eldon Census, and trying to tell you a little bit of the story of why we're trying to raise that endowment right now, and that is to support these kind of facilities and infrastructure so that our students can continue to have that project-based hands-on learning. So hopefully that wasn't too quick and didn't make people get dizzy or motion sick. All right. Are there any additional questions that anybody have?
I don't see any right now, but if you have one, go ahead and put it in the Q&A box there, and we'll ask Dr. Larochelle as he gets settled back in his office there.
I'm back here, so I'm going to get back on the desktop.
All right, so anybody have a question? Here we go. How many ME students attend South Dakota Mines, Dr. Larochelle?
Round number is 600. We are just under 1/3 of the student body of the School of Mines. We are 3 times bigger than the next biggest group on campus. We are the big monster on campus.
And how about, can you break it down a little bit? How many freshmen and then how many seniors? Maybe coming into the fall, I would guess, or
Yeah,
in
so we're expecting somewhere between 135 and 150 this fall in our intro course. In senior design, we'll have 110 to 115.
somebody said, great tour, lots of continuing positive change. So they liked your
All right.
tour. Yeah.
Okay, well, hopefully I didn't, I wanted to move quickly, but I didn't want to move too fast to get people dizzy. So I don't know. Hopefully that gives you a little feel, especially if you're remembering back to when you were here and oh, that looks different and things. We're trying to keep up and be on the cutting edge all the time, right? So we always have to make some changes.
All right, we have one from Paige Ling. When was the aerospace minor established?
It officially launched in August of 2021. So we just finished the first year of aerospace minor, and we had our first graduates in spring of 22. So we had seniors already enrolled in the minor and received the minor when they graduated in May.
Those are all the questions right now, but if somebody has one, we have time. So if you have a question, it's a great time to ask. A couple of thank yous in the chat.
Great. Let's see in the chat.
I did put the Census Lab endowment link in there, so that's in
Okay.
there. A lot of comments. Here's one. I work in building design as an HVAC ME, but electricals can write their ticket right now in building power distribution, computer and micro electronics. Industry is stealing all double E's away. Just a comment there. And there's Dr. Larochelle's email. If you have other questions later, you can email him that way.
Yep.
Or other comments. Yep.
Yep,
Well,
there's my email and there's my phone number. So if you have any questions or comments or thoughts, or you just want to reach out and share a story, I'm always happy to chat with our alums. It's one of the highlights of my day. I really sincerely enjoy it.
excellent. We'll do a last call for questions here. Yeah, we do have a little time. Okay, well, great. Well, Dr. Larochelle, thank you. Appreciate having you here at South Dakota Mines. It's a pleasure working with you. I know in our work that we do together, really focused on alumni relations and development. You're a role model for us across the campus. So thank you for all that you do, and want to thank everybody that's been on today too. And I know many have already donated either to scholarships to support students either in ME or other departments or even the Census Lab. I want to grateful to all of you out there. So a couple just upcoming reminders. On the 21st of July, we'll have our digital lunch and learn. It's going to be about estate planning. And Leah Mahoney, who's our director of plan giving at CARA, will be on, but she'll be joined by Bobby Turry. Bobby is an alum of the school. You think of all the MEs and all the engineers and all of that. Bobby went into law, and she's an estate planning attorney in Sioux Falls. So she will be on for that. And then on August 4th, that's at 11 a.m. Mountain Time, August 4th will be department update, art and engineering, which I think will be really interesting as well. So all of our other events are out on Facebook and LinkedIn and in our website as well. So there's one more question. Is there still a computer science course required for MEs?
Sure, absolutely. Our students are required to take CSE 170, and currently in that course, they're learning Python programming.
And then within aerospace program, are there mechanics courses, elasticity, plasticity, et cetera?
Yeah, there's a required aerostructures course that covers the specialized mechanics topics for aerospace. And I got to say, very kind introduction, Paul. That was very generous and kind. Thank you very much.
Oh, I mean it though. It's true.
Okay. Oh, well, thank you
It's
very
true.
much.
Yeah.
Well, I enjoy
All right.
working with your team as well.
Thank you. All right. Well, if there's nothing else, we want to thank all of you for being here today and hope you join again at one of our future updates. And we want to get you back on campus too. So I encourage you to come back for Rocker Days or anytime you're around. Rocker Days is the 19th through the 24th. And great chance to see our faculty and students in action and enjoy the weekend. So encourage you to come back anytime. You're more than welcome. And again, a thanks to Dr. Larochelle for being with us today. And everyone have a good rest of your day and go Hard Rockers. Thank you so much for being here. Take care. Bye.
Bye.